Please welcome Mustafa Erkaya, a master's student in biology from Istanbul, Turkey.
Recently, many people started getting DNA tests from companies like these to understand their genetics and also their ancestry profiles. If you've taken one of these tests before, this top image might look very familiar to you because the middle one is you and the right one is your fifth-degree cousin. Now, we're also trying to recreate images like these in animal studies as well. And while doing so, we tend to use what we call mitochondrial DNA. Now, mitochondria is an organelle that's found in the cell, just like nucleus, and the cool thing about it is it has its own DNA. Now, that mitochondrial DNA, although it works well in several animal groups, while creating those life tree images, about 20% of the time, we tend to see a discordance, an inconsistency between genes that are located in mitochondria and not located in mitochondria. Now, companies like these achieve this problem by using both mitochondrial and non-mitochondrial DNA. But this can be very costly. So we're looking for more gene groups that are not located in mitochondria, yet are variable enough to give us valuable data. Although I study these little cute creatures, reptiles, and their population genetics, I use gene groups that have never been used before to study this kind of stuff. The gene groups I use play a role in fertilization, not only in reptiles, but also in other animals, including humans, which makes them superior candidates. Now, the second problem comes from the basis of the genetic studies. They're either faulty or missing data, or they're just too expensive to replicate. Now, we have the technology, but for many schools out there, they're not affordable. For example, this is a DNA sequencer. This machine can cost you several $100,000, or maybe millions, just to purchase it, yet the cost does not stop there. Running them with the appropriate cartridges can add up the cost very easily. Now, some of you might be thinking, hold on a second, buddy. I took a DNA test last year, and it only cost me $100. Well, the point is, you spend $100 only on yourself as an individual. But as a scientist, I work with several hundred animals, and the cost can add up very, very easily. So my project plays a role here, and it takes an amazing shortcut. The gene groups I use are short enough to sequence for very cheap costs, yet they're long enough to give us very variable and valuable data. So if I can show and prove how we can use these gene groups to study the relationship between different populations of the same species, we're going to be able to understand their evolutionary basis even better, and this revolutionary method will be put into use right away. Thanks.
Thank you, Mustafa. So I bought my wife a 23andMe for Christmas this year, and it cost me, I don't know, like $150. When they first started doing genome sequencing, how much did it cost to do that?
So a few decades ago, like 20, 25 years ago, the first human genome sequence for over $3 billion. And
$3 billion?
$3 billion. And now they do it, some companies do it for only $200. And it's just amazing. Like, I lost my grandfather yesterday due to Alzheimer's, and screening my family, if they have this or not, just puts me in so much comfort. And fortunately, they came back negative. It's perfect, you know.
Very sorry for your loss.
Thank you.
Vice Provost Granis, if you would give Mustafa some feedback, please.
Thank you, Mustafa. That was a great presentation. I thought you did a really nice job of kind of starting out with something that a lot of people would kind of understand, and even if they maybe haven't done their own DNA testing, they've had friends or relatives who have. I have to say I've done the 23andMe, and I keep getting pinged with these emails that say, you have a new relative in the system. It's a little disconcerting. I was like, how many people am I related to? But I really liked how you kind of walked through from that sort of generalized starting point, and then you went finer and finer and finer, and how you brought in the slide, each sort of the different components that when I saw the slide at first, I'm like, how does this all tie together? But you wove that thread throughout and explained what each of those different segments of the slide was. So I liked how you kind of wove that in, and then brought it back to the end of what's the big picture of getting as much out of this data as you can for the most efficient and effective and cost-effective way to do it. And that's how we advance science. So thank you.
Thank you so much.
Thank you, Dr. Granis. Thank you, Mustafa. All right, next up we have Joshua.